is Darsh and welcome to D Brothers. Today we're going to be covering factoring. Before we start, don't forget to like and subscribe and hit that notifications bell. So let's get started. So first, we're going to want to know what factoring is. Factoring is just making one number into a multiplication problem of two or more. It's just another operation like addition, subtraction, multiplication, and division. Except then you're given two or more numbers and you have to turn it into one number. Here it's the opposite, one number to two or more. So let's get an example. Let's use 6. So when we factor, we're going to want to know what factors are. So the factors of a number are anything that number will divide easily into. Anything that's 6 will divide easily into without any remaining numbers or remainders. So I can think of 1 straight away because 6 divided by 1 equals to 6, no remainders. That's not a 6. This is a 6. That's 6, no remainders. And then I can think of 2. 6 divided into 2 equals to 3, no remainders. And then I can think of 3, 6 divided into 3 equals to 2, no remainders. And then I can think of 6 itself. 6 divided into 6 equals to 1, no remainders. Those are the factors of 6. 1, 2, 3, and 6. So we can't just write them down like 1, 2, 3, 6. You could do that when you're asked to list all of the factors of 6, but not here. Here we have to make the factoring expression. So let me erase that because that's wrong. So we have to make the multiplication expression and it has to equal to 6. So let's start with 1. 1 times 2 won't work because that equals to 2. 1 times 3 won't work, that equals to 3. 1 times 6, yes, that's perfect because 1 times 6 equals to 6. So one factoring expression could be 1 times 6. But we still have 2 and 3 left over. So there could be more than one factoring expression. You're allowed to use whichever one you want, or both, if you're asked to. So 2 times 3 equals to 2 times 4 equals to 6. So that is also another one of our factoring expressions. So that's all with factoring, but there's something that factoring is involved in, and that's called prime factoring. Prime factoring is when you factor, but you have to make sure that all of the numbers you end up with are prime numbers. Right now you're probably wondering, Darsh, what are prime numbers? Well, prime numbers are numbers that only have 2 factors, 1 and itself. So I'll list 3 for you right here. There's 2 because 2 times 1 equals to 2, and there's nothing else that you could multiply to get 2. And then there's 3 because 3 times 1 equals to 3 for the same reason. And then there's 5 because 5 times 1 equals to 5, and it's for the same reason as 2. So you could do prime factoring like this. Now we're going to be using the tree method, the factoring tree. So the factoring tree is something that we could do with this one as well. So we'll set prime factoring aside, and then we'll look back on this. So tree factoring is something that you could do with any kind of factoring. So tree factoring this would just mean putting 6 down and then branching it out to the 2 factoring expressions. There's 1 and then 6. That's a tree. And then you could also do 6 and then 2 times 3. 1 times 6 and 2 times 3, they both work. So we're going to be using that method to do our prime factoring. So let's take good old 6 and prime factor him. So we have 6, and then let's use one of these factoring expressions. First, let's go to 1 times 6. So that's our factoring expression, but That's not a prime factoring expression. 1 is not prime, but we can leave it alone because we don't have to turn it into a prime number. And it's not a prime number because, as we know, that prime numbers are numbers that have exactly 2 factors, 1 and themselves. But 1 has 1 and itself, but itself is 1. So it only has really 1 factor, which is 1. And that doesn't satisfy the meaning of prime number. So that's not a prime number, but we can leave it alone because it's just 1. So now 6. 6, you are not a prime number. I will change you. 6 can go into 2 times 3. 2 and 3 are both prime. They're right here, 2 and 3. I can just bring down the 1 now, 1, and put down that multiplication sign. So our prime factor expression is 1 times 2 times 3. And since 1, if you multiply anything to 1, it'll just equal the same number, we can just take that 1 away. And our factor expression will just be 2 times 3. That's it. So let's try the same thing with 2 times 3. So 6 can it can become 2 times 3. 2 times 3, not 6. And same thing. That's already prime. 2 and 3 are both prime. We don't need to do anything. There's easy peasy. Same thing here. So they're the same, even though we use 2 different factoring expressions. So now we learned that you have to get the same expression if you're doing prime factoring. It doesn't matter which factoring expression you use, as long as you get the same prime. Okay, now let's do one more example of a prime factor thing. So we can use a big number this time. We can use, let's use 36. Bigger number, much bigger number. 36. 36. 36. So we know that 36 can become 4 times 9. That equals to 36. 4 is not prime. 9 is not prime. So we have to factor them both. So now we factor 4. 4 will become 2 times 2. We could actually, instead of 2 times 2, let's go for something a little different. We could go for 1 times 4. So 1 is not prime, but we can leave it alone. But 4, you are not prime. So 4 can become 2 times 2. 2 and 2 are both prime. We can leave that one there because what we learned here. So we put down that multiplier. We don't need that actually. So 9 can become 3 times 3. There. So that will become 3. We can just bring down those. So 3 times 3, and then that big multiplication sign, you come right here. So we could leave that one there because 1, if you multiply into anything, it will always just be the same number. So we don't need to use the 1. And here we have our expression, 2 times 2 times 3 times 3. Now let's do another one of those. Now let's do it horizontally, actually. So now we can do 36 again. 36. So 36 can also go into 12 and 3. So it's a bit high, it'll crash into that. So let me just write that again a bit lower. 36 can go into 12 and 3. So 3 is already a prime number. We can leave that alone. And then 12. You become 6 and 2. 2 is a prime number. We can bring this 3 down here. And then multiply, and then multiply. But that 6, that still isn't prime. So what we'll have to do then is put it into 2 and then 3 times. Okay, now we can bring this down 2 times, and then we can bring this 3 always, and then there we have it. 2 times 3 times 2 times 3. So 2 times 3 times 2 times 3. It's still the same thing if we just rearrange it. There's still 2 times 2, and then 3 times 3. It's still the same. So it just reinforcing what we just said. No matter which expression you use, you always have to end up with the same prime factoring expression. And that's factoring and prime factoring. So yeah, that's it for today. Bye.